So this was the problem that you had to do from your notes, and you'll notice that this one doesn't have any context. It's just an input-output. We're not talking about gasoline or anything here. So we need to list off the domain. The domain is all of the inputs, also some usually are x, and so put my bracket 0, 1, 2, 4. That is my domain. My range is my list of outputs, and that is 1, 2, 5. Notice that I didn't write 2 twice. You don't have to, right? If you wrote 2 twice on there, it's not that big of a deal. But anytime you have a repeat number, it is not necessary to write the repeats of it. In fact, a lot of times it's easier if you don't write the repeats, okay? So if you've got any questions about domain and range, make sure you leave a comment or ask me. But let's go ahead and move on to our next concept here, where we're talking more about functions. So remember what we said earlier, that a function has a pairing of inputs with outputs such that each input is paired with exactly one output. Well, one of the ways that we can represent a function is called a mapping diagram. And a mapping diagram helps us to see how these pairings are set up. Now, this over here, I will tell you, is a function. But you might say, well, look, this input goes to do different, you got 2 inputs that go to the same output. That's okay, right? Each individual input should only go to one output. This input goes to one output, and this input goes to one output. And so it's okay. It's a function, right? So that's notice that an output may be paired with more than one input, but it can't be the other way around. So this over here is called a mapping diagram, and you just write your inputs in one column, your outputs in the other column, and then you draw a line to where those inputs, where the pairings match up. So let's do an example of that on the next page here. So tell whether the pairing is a function, okay? So let's do A first. We don't need to make a mapping diagram for this one. We can just kind of look at it. So we have to ask ourselves, does each input have exactly one output? 10 goes to 5, that's 1 to 1. 5 goes to 4, that's 1 to 1. The 0 goes to 2 and 3. This is not a function, because an input cannot have 2 separate outputs. Think of a function like a machine, right? It's a simple machine, right? If I put something in, if I put one thing in, I should get one thing out. But if I put one thing in and I got multiple things out, it's not a function. So this over here isn't a function because this input goes to 2 different outputs. Like I said from the previous slide, remember, having 2 inputs that go to the same output, that's okay. This is a function. But the other way around, an input to 2 outputs, not okay. So that's part A. Let's do part B. Let's draw a mapping diagram for this. So again, we're going to make our inputs in one side, and we're going to make our outputs in the other side. So the inputs are going to go 0, 1, 4, 6, and the outputs are going to go 0, 2, 8, 12. And the way that we draw the lines is simply that this 0 is paired with this 0, so that goes across. The 1 is paired with the 2, so that goes across. The 4 is paired with the 8, and the 6 is paired with the 12. And notice that it's 1 to 1 all the way down, so this is a function. Key thing on here, and where we make the most mistakes, is this part right here, right? An input with 2 outputs is bad. An output with 2 inputs, that's okay. All right. Got a couple of practice for you to go back to on your notes. Go ahead and do those, and we will see you in the next video.